Okay, so today's our next topic is elastic collision in one dimension. Okay, so as you guys all know, we have discussed that elastic collision is known as the isolated system in which the kinetic energy was conserved as well as momentum was conserved. Okay, so as you guys all know that we have started before that elastic collision and inelastic collision both. So today we are discussing elastic collision in one dimensional. What does it mean? It means that as you guys all know, in elastic collision the momentum and the kinetic energy was conserved. Okay, so for example, this is mass 1 and it's moving with a velocity 1. It's mass 2 and it's moving with a velocity 2. Okay, when they are collide with each other like this, m1 m2. Okay, so this I can write here that it become u1 and it become u2. What does it mean? It means that this was the before collision, initial collision, you can say that, and this was also the before collision. Okay, and this is after the collision, or you can say after the collision final velocity, and you can say that after collision final velocity. So we are known that this is mass 1 and this is body 2, which is having mass 1 and mass 2, and they are moving with a certain velocities. Okay, when they are collide with each other and they are getting a final velocity that is unknown. Okay, we have to find this. So to find u1 and u2, or you can say that the final velocity of that two bodies after the collision, to find the final velocity we are having a derivation of this to find the u1 and to find the u2. Okay, so first of all we'll be finding u1 then u2. So let's start. So as you guys all know, the law of conservation of momentum states that m1, we were having a equation of law of conservation of momentum. As you guys all know, we did that too. So we were at the product, we get the equation that was m1 v1 plus m2 v2 is equal to m1 u1 plus m2 u2. This was the before collision. Okay, like this, m1 v1 m2 v2, m1 v1 m2 v2, and this was after collision. Okay, this is m1 u1 m2 u2, m1 u1 m2 u2. Okay, so this was the before the collision. Okay, so you can say that to find the, you can say that collisions after that, so we can arrange then that m1 v1 is equal to, or you can say minus m1 u1 is equal to m2 v2 u2 minus m2 v2, like we have to find this is a before collision, we have to find after initial collision of that body. So we have like this m1 v1 m1 u1 m2 u2 m2 u2 and m2 v2. Okay, so as you can see, this m1 is common in that because this is v and this is u, so m1 is common and v1 u1 is here. Okay, now in that, in these both, m2 is common and u2 minus v2 will remain here. So this was equation number 1. As you guys all know that momentum and the kinetic energy was conserved. Okay, so we have finded the momentum of this. Okay, to find the kinetic energy, momentum was also conserved, kinetic energy was also conserved. Now as you guys all know the formula of kinetic energy, that is 1 upon 2 mv square. Okay, so we have to arrange this equation into this. Okay, so 1 upon 2 m1 v1 m1 v1 square, okay, plus 1 upon 2 m2 v2 square, okay, 1 upon 2 m1 u1 square plus 1 upon 2 m2 u2 square. How? 1 upon 2 same, okay, we were having a m1 v1, so m1 v1, but here square is there, so we have put it square 2. 1 upon 2 m2 v2, m2 v2 square is there, we have put it square. 1 upon 2 like that, m1 u1 square m1 u1 square, and that 1 upon 2 m2 u2 square. Okay, so as you can see that this is having a, you can say that we have to arrange those all. So this here you can see that this one m1 u1 is like here, it is in positive side, we have to get that as a negative side. So we can write here m2 1 upon 2 m1 v1 square minus m2, or 1 upon 2 sorry m1 u square u1 square is equal to 1 upon 2 m2 u2 square minus 1 upon 2 m2 u2 square. Okay, so here you can see that we have changed this, v1 u1 was there and v2 u2 was there. Okay, so we have just changed this all. Okay, so here you can see that here it was positive and it's moved in that side, it become negative, and here it was positive, it moved there side, it become negative. Okay, so here you can see that this can cancel with each other. Okay, this will cancel with each other. So we have found the equation that is m1 v1 square minus v1 square m2 v2 square minus v2 square. This is question number 2. This is question number 2. We have taken m1 here. Okay, we have taken, this is u1, sorry, u1 and u2. Okay, you can see that we cut these all because they were same. So m1 is, you can see that m1 is same, so it will be coming outside, and v1 square minus m u1 square, here the common was m2, so u2 square remain, and you can see that this is v2, sorry, v2 square remains same and u2 square remains same. This was question number 2. So we have found equation number 1 and 2. So now we are dividing equation number, you can say that 2 by 1, because to obtain the velocity, because we have to find the velocities, as you guys all know that final velocity u1 and u2. So first of all we will be finding u1, so let's see how we will be finding. But first of all, before we have to obtain these both velocity, so we will be dividing both equation. You can write here, divide equation number 2 by 1. Okay, so here you can see that m1 v1 square u1 square is equal to m2 u2 square minus v1 is v1 square. Okay, so here you can see that this was the equation number 2. Okay, now we have to divide that by equation number 1. Equation number 1 was m1 v1 minus u1 m2 u2 minus v2. Okay, this was equation number 1 and this was equation number 2. We are dividing equation number 2 by 1 to obtain the velocities. Okay, so here you can see that we can cut these all. that they are same. Okay, so here you can see that here the formula is obtained in maths. We have studied that if a square minus b square is there, so it is equal to a minus b and a plus b. So here you can, we are having squares and minus sign too, so we have to obtain this formula. Okay, we have to obtain this formula on the where the squares are there. So as you can see in equation number 2 there are square, but in equation number 1 there is no square. So we'll be applying this formula into the equation number 2. See how. Here you can see v1, okay, minus u1, v1 plus u1. Okay, this a minus b, a minus b, a plus b, a plus b. Okay, here you can see, you will also do the same, u2 minus v2 and u2 minus v2. Okay, and this equation will remain same like this, v1 minus u1, and you can say that u2 minus v2. Okay, so here you can see that this equation will have cancelled by this one and this one to this one. So final equation we had, the equation is came, that is v1 plus u1 is equal to u2 plus v2. So this is equation number 3, and it is of all velocities, all the velocities. But what we have to find? The final velocity of u1 and u2. Now we have to find the final velocity. So for that we will be finding the, first of all, u1, then we will be finding the u2. Okay, so as you can see that to find the value of the u1, so we will be finding that, so we are having a equation that, okay, so to find the u1, first of all, this was the equation and we have to find what? u1. So as you guys all know, to find the u1 we will separate u2, and to find the u1 we will separate u2, and to find the u2 will be separate u1, like this we have to find u1, so we will be separating u2 from there, and this equation is there. This is the equation to find the u1. But what if we have to find u1, so it will be u1 we have to find, so we are having separate the u2. But if we have to find the u2, we will be separate the u1. Okay, so why we are doing that? Because so that we cannot apply the substitution method, because it's too long, as you guys all know. Okay, so to find the u1 we have separated the u2. So because we are finding the u1, so we have separated u2. Here you can see u2. Okay, so this is you can say that the equation. Okay, so here was the equation, this was u2, sorry. Okay, so we have u2 separate here and is equal to these all equation till here. Okay, so now we have to put this u2 value in the equation number, first equation, that was this one, you can say that one, equation number 1. Okay, so we have to put the u2 value into the equation number 1 to find the u1. Let's put and see how the u1 is coming. Okay, so we have to put the value of u2 into the first equation. Okay, so we are having an equation m1 v1 minus u1 is equal to m2 is equal to m2. You can say that this is we are having that one equation, that is v2 u2 minus v2. Okay, so here you can see that we have to put the u2 value in the equation number 1. This is equation number 1. So we have written the same. Okay, so if we have to put the u2 value into the u2 value here of this, the value we are having v1 plus u1, v1 plus u1 minus v2, v2 we are having v2 here too, so we can write here minus 2v2. Okay, so here you can see that we are having this one equation m1 v1, because m1 multiplied by v1 is equal to this minus m1 multiplied by u1 m1 u1. Okay, m2 v2 m2 v1, we have multiplied this, plus m2 u1, and you can see that the here you can see that plus minus minus, so m2 2v2 square, m2 2v2. Okay, so here you can see now we are having m1 v1 minus m2 v1. Here you can see that here the equation is of v1 u1, so here I am gathering the v1 equation. So here you can see that we are having a 1 v1 value, that is here, so it's here plus positive, it will be coming here, it will become negative. So I can write here that this one, like you can say that this one, yes, plus 2m2 v square. Okay, how, let's see. So we were having this one equation 2 v, so we have separated this here too. Okay, so now here you can see that m2 u1 plus m1 u1, m2 u1 m2 u1, and you can see that here the m1 u1, here this one value, it was negative here and it become positive here. So we have just separated the v values here and u values here and exchanging the signs. Okay, so we can write here 2m 2v2, we have added these all, so it become this. Okay, so here you can see that the positive m1 v1 minus m2 v1 is equal to u1 m1 plus m2. Let's see how. Here you can see that we have just we did this one, like this was m1 v1. Okay, so we have, you can see that here this one was the positive one equation. Okay, we were having a positive equation, so this larger value become here and this one value is here and this minus 1 value is here, and you have seen that here u1 is common, so we have taken u1 here and m1 and m2 are remain same. Okay, so here we can write here that we have to find what, u1. So we can write here u1 is equal to 2m2 v2, this one. Okay, plus v1 m1 minus m2. Okay, and here you can see that m1 plus m2, here we have put it this one value. Okay, and v1 was common, we have put it this v1 common, m1 and m2 is remain same, and this area is multiplying, it will be coming down, so it will divide. Okay, so the final equation of u1 is 2m2 v2 2m2 v2 plus v1 m1 minus m2. Okay, m1 minus m2, and here you can see that m1 plus m2, and here m1 plus m2. It is here with both equations, so we have written both. Okay, so this is the value of u1. How we have find it? To put the value of u2 in the equation number 1 to find the u1. Now we have to find the, you can say that u2 value, so we will be separating the u1 equation. So first equation we was having, that was v1, third equation, that was this. Okay, so we have to find what? Equation number 2. So we will be separate u1. Here you can see like that was same equation. To find the u2 we have separated the u1. Okay, so we have to put the u1 value into the equation number first. So we are having equation that is m1 v1 minus u1 is equal to m2 u2 minus v2. Okay, this was equation number 1. To put the value of the u1 in the equation number 1, like this, m1 v1 minus u1 have value is, you can say that the u2 plus v2 minus v1. Okay, and this will remain same, u2 minus v2. Okay, so here you can see that m1, and here you can see this v1 and v1 become 2v1, and this will remain same, u2 plus v2. Okay, and this will become same like this. Here m2 multiplied by u2 is equal to m2 u2, m2 multiplied by v2 is equal to m2 v2. Okay, now you can see here that is 2 m1 v1, if we are multiplying this, minus m1 u2, we are multiplying this, and we are multiplying this, so we have become m1 v2. Okay, so here you can see that we are having the same, this one value here. Okay, after that we are having the, you can see here 2 m1 v1. So we are having u1 value here and u1 value here. So here v value is there, and you can say one more, you can say we are having this one value, we are like separating v values and u values. So u1 value will become there and v1 value will become there. So we can write here that m1 v1 v2 plus m2 v2 is equal to m2 u2 and plus m1 u2. We have just separated the v1 value and u1 values. Okay, after that we can write 2 m1 v1 minus m1 v2 plus, you can say that m2 v2, and we are having common here we are having common here, we are not having common one, we are having u value common, so we can write here m1 plus m2. Okay, so here you can see 2 m1 v1 plus m2 v2 minus m1 v1. Okay, so here you can see that what we did, the greater values become here and this one become here. Okay, so this remain the same. Okay, now you can see that we are having a 2 m1 v1, and after that we are having in common, we were having a common that this is 2. Okay, sorry, so this is 2, so we are having a common here, you can see here that is v2, and m1 minus m2 is same, is equal to, here you can see that we can write u2 m1 plus m2. So we have to find the u2, here it's like multiplying, it will be going here, it will be getting. Okay, you can write here 2 m1 v1 plus v2 m2 minus m1. Okay, the same values there, and m1 plus m2. So we can write here it's here it's here with the whole equation, so we can write here u2 is equal to 2 m1 v1 upon m1 plus m2 plus, you can say v2 m2 minus m1, and here it's remain same. So here we have got the u2, you can see here, and here we have got the u1 with the help of the u2, and here we have get the u2 value with the help of u1. So we have find it the both, you can say that the both final velocities, that was u1 and u2. So through that you can easily find out the final velocity with these both. You can say that from the, if there is a question you have to find u1 u2, so from that one formula you can easily find out that what are these. Okay, so for finding those all we are having special cases, and then I'll be telling you how to find if there is a question that you have to find the u1 and u2, and how to we will be finding those, like you can say that answer with the help of these both equation we have derived u1 and u2. So that we'll be doing in the cases. So tomorrow we'll be doing the 4 cases of this topic, and we'll be watching out that how to find the value of u1 and u2. Okay, so today we have did the derivation of find, or you can say the formula of the u1 and u2.